Start of Unit 7, dealing with solutions. So first thing here, what are solutions? This should be review from way back when, at the beginning of the year, but matter divided into a couple of things: mixtures and pure substances. Pure substances, we have things like compounds and elements. Mixtures, we have things called homogeneous mixtures or heterogeneous mixtures. Another name for homogeneous mixtures are solutions. So same composition throughout. It says components are indistinguishable, meaning you can't tell the difference, and we'll talk about that as we go through each. Definition: homogeneous mixture made of two or more substances. Here, components retain their identities and properties. So if you want to think about, well, we'll see a bunch of examples down here. Solutions can be a number of things. It could be a combination of solids. We call these alloys. A lot of times we talk about metal alloys. Like if you're a baseball player, that baseball bat is a metal alloy made of aluminum, probably some chromium and nickel, and maybe even in a bunch more. I'm sure there's patents out there for kind of that ratio that it's talking about up here. The atmosphere, mixture of gases, so it doesn't just have to be a liquid and a solid. Think about the atmosphere. Look around you. You cannot, those particles are so small that you cannot see the difference between the nitrogen and the oxygen and all the other gases in there, but yet they're still retaining their properties. We're breathing in oxygen. It's, the oxygen is what's reacting in our blood, to keep us alive. So it retains the properties of that oxygen or of any other part. Special type of solution here, and this is the one we're going to talk about the most, but if it consists of something dissolved in a liquid, doesn't have to be a solid. We can dissolve gases in liquids, and we can dissolve other liquids in liquids, but the liquid component is what we are going to call the solvent. The solute is what we are dissolving in that. So watch your two S words here. Be sure to know the difference between each. When H2O is the solvent, we call this an aqueous solution. We've seen that before. When these things dissolve and dissociate, we call electrolytes. Talk about them later. Concentration. Talk a lot about it. There's a bunch of different ways, and this isn't all of them, but we will focus on two of them. So concentration, measure the amount of solute dissolved in solution. Examples, like I said, there's a bunch out there. You might take another chemistry class later on or a different class later on where these matter. For right now, we're not going to worry about them. We are going to look at molarity and then something called molality. Molarity, big M. In lab, you have seen beakers, you have seen glass bottles that say like 0.5 mHCl or something like that. This stands for molarity, which is a concentration. So the number of moles of solute per 1 liter of solution. The one we're going to use most often. We'll see it in lab a ton. Example, a 1 molar solution would contain 1 mole of solute, whatever that is, for every liter of solution. Question here, example, try this on your own. We're going to do practice like this tomorrow, but see if you can try this on your own without my help, just using that equation and see what you come up with. The other one then is called molality, so little m, notice the difference. This is the number of moles of solute per kilogram solvent. So if we kind of go back and forth, notice the difference there in the units for what's on top, what's on bottom. So a 1 molal solution would contain 1 mole for every kilogram of solvent. And then example here, again, try it on your own. Look at your units, look at what you're given, and look at your substance and see what you need to convert first before plugging into that equation. And then just some more practice that we will continue working on tomorrow.